All right, section 3.3. We're going to talk about lines again, like we've been doing. We've been talking about parallel lines, and we are going to talk about a little bit about parallel lines today, but we're also going to talk about how these lines actually slant. And this is an Algebra 1 topic, so this should be familiar to you. And somebody said it over there, heard it. Slope, that's right. All right, so if I had a line, watch this. If I had a line like this, and you can put arrows on the end. You don't always have to have the arrows on there. Sometimes a little lazy, don't put them on there. But you got a line right here. This is the X and Y axis. We've talked about that earlier in the year, didn't we? This is the X axis. This is the Y axis. And we have a line. It's got a certain slant to it. So if I took this line and let's scooch this down like this. And let's see if I can do this. There we go. So these lines have different slants to them, don't they? And we'll just make a different color. Alright, so these lines have different slants, and so one's going in one direction, one's going in the other direction. Let's talk about the red one first. Look at the red one. Now we read from left to right, so I'm looking at this line from left to right. So if I go from left to right, am I going up the hill or down the hill? Going up the hill, right? Sometimes I've seen books do this. Draw. Don't make fun of my car. There you go. Looks like a... it looks like... I don't know what it looks like. It looks like my old minivan, kind of. Had that big, long nose like that. Anyway, so that's my car, right? So I'm going up the hill, right? So when we talk about the slant of a line, we don't really say the word slant that much. What do we use? We use the word slope. Okay, we talk about the slope of the line. So let's just talk positive, negative. If it's going up from left to right, if you're like in a car and you're going up the hill, then this would be, what kind of a slope do you think? It'd be a positive slope. Good. So that's a positive slope. All right, because it's going up. You can just look at it and just determine what kind of slope it is. Now this one, if you're going from left to right, what would you be doing? You'd be going down the hill. All right, here's my cool car again. And you're going down the hill, right? So this would be what kind of a slope? So it'd be a negative slope, all right? That'd be a negative slope. Everybody with me so far? Let's look at this one. What if the slope was going completely horizontal? Let's just move it down like this. It doesn't go up a hill or down a hill, does it? It's completely horizontal. So this right here, now write this down, this right here has a zero slope. Zero is a number, okay? And it has a zero slope. I think of when I go skiing. If I'm going to go skiing and I just stand there, because you go on the slopes, right? They say I'm going to hit the slopes, right? Don't they? People go skiing, I guess, say that. And I've heard that before. So if you're going skiing, if you just stand there and nobody's pushing you or anything else, you just stand there, how many miles per hour will you be going if nobody pushes you? You'll be going 0 miles per hour. This is a zero slope. The slope still exists. It is a slope. Okay, it's like a bunny slope. You ever hear that? Yeah, anybody go skiing? All right, you go on the bunny slope, okay? But a bunny slope actually does have a slant to it. Throw it away. I give you 3 times, all right? Yeah. Big sigh because I'm the bad guy, right? Yeah. Even though I told you before, I should be writing you up right now, I'll tell you the truth. So don't give me a big sigh. You should be grateful to me that I just allow you to throw it away, nothing else. Here we go. So that green one has a zero slope. Let's do another color. Let's do blue. What other kind of line do you think you might have? You have a horizontal one. You got one that's slanting up to the right. You have one that's going down, to the right. It's going down, it's going up, it's going across. What do you think? Up and down, straight up and down, which would be what kind of a line? A vertical line. So the green one is horizontal, and this one right here is going to be blue. We're going to put it about right here. And this is going to be vertical. You see that? Now look at this. Let's think about going skiing again. For you guys who have been going skiing, okay, Javi laughed because, have you ever been skiing? You haven't been skiing? You should go sometime. Tell your friends on the islands you went snow skiing, okay? Have I? Yeah, I've gone skiing quite a bit. Different places. Pennsylvania and Virginia, and yeah, no, I'm pretty good actually. I can ski pretty fast. Yeah, yeah, I've fallen before, but that's I've not hit a tree. No. So watch this. I don't snowboard now. No, I shouldn't. I'm too old for that. So watch. Look, here's a person up here, right? If you go skiing, they label all the ski slopes, okay? They label them with these colors, okay? Like a green is like really easy, blue's a little bit harder, and then the blacks are really, really difficult. And they have things called, they have black diamonds, right? You go to the double black diamond, and it's really, really steep, okay? It's a very, very steep slope. But there is no place in the world that has a slope so steep where it's completely straight up and down, all right? It doesn't exist. Did you hear what I said? Now, you may not have understood what I just said right there, but it's very important. That slope does what? Not, what did I say? Exist. It doesn't exist. All right, now there are hills that go straight up and down, but we would never consider them a ski slope. All right, you would never consider that a ski slope. All right, because you couldn't ski down it. You would just fall down it, wouldn't you? This is not a slope. It's not a zero slope. Horizontal is zero slope. All right. For instance, if I actually did go down this, then I would go all the way to the bottom, and guess what? I would be dead. There would be nothing. There would be nothing that exists of me, okay? I would hit the ground, all right, and I would not exist. Do you hear what I'm saying? It does not what? Exist. It doesn't exist, okay? Or down the bottom, if they tried to identify me, they probably couldn't. Okay, I would be unidentified. Okay, you couldn't identify me. So there's a couple ways you could talk about this slope right here. So this type of slope, a vertical slope, it does not exist. You could just say that. It does not exist. All right, so that's one way to say it. Or you could say that it's undefined. Think of me being down the bottom of it. They wouldn't be able to tell who I am. I would be what? Undefined, right? So this slope right here, you could say it does not exist, or it's undefined, or another way a lot of people like to say it is you could say this is no slope. That's different from zero slope. Zero is something. Zero is a number, all right? Zero is a slope. You can have a slope that's zero. You cannot have a slope that is vertical like this. Everybody understand that? Okay, so that does not exist. So that's the first thing about slopes, okay, is all that stuff. So let's do this. Let's copy and paste the X and Y axis again. So that was pretty important stuff right there. Let's do another thing. Let's actually talk about how to find the value of that particular slope. All right, so let's take a look at this. And you probably remember some of this from Algebra 1. If you're going to find how steep this is, what you're going to do, you're going to make a comparison. Let's start from here. You're going to take from one point to another point. And you're going to make a comparison. What you're going to do is you're going to find out how high you go compared to how far across you go. See what I said? Okay, you're going to compare that. Now, if I did this, or if I compared 2 points that were closer to each other, guess what's going to happen? This height and this width right here is going to come out to a fraction. It's going to come out to the same exact fraction if I do this divided by this. The slant doesn't change, does it? Is it any steeper right here than it is from here to here? It's the same exact slant, right? It's not like we're going steeper, then we're going more shallow, and it's the same exact slant. So no matter what points you pick, you're going to get the same exact slope. Now, in Algebra 1, what do we call this up and down thing right here? It started with an R. Do you remember that? You don't remember that? I.
Right.
I guess you didn't hear this. It's a rise. Nobody's heard of that? The rise. And what do we call this one that's going across? The run. See, you did hear it. I know it was in there somewhere. So to find the slope of this thing, now watch, this is very important. To find the slope, or how much it's slanted, we take 2 points on that line and we figure out how far from here to here it is, the rise. All right, so we take the rise. And what do we do to the run? We divide it by the run. So then we take from here to here, we figure out that length. So figure out this length, figure out this length. It's the rise over the run. And that's how you do slope. Slope is the rise over the run. That's something you need to have memorized. I mean, that's something that math students, they just know off the top of their head. It's rise over run. Okay, you take how far up and down you go, and you compare it to how far across you go. Because if you had a line like this, Or, oops, sorry. Let's do this. Let's copy and paste. All right. And let's change the slant of it slightly. Like that. Okay. And we'll make it a different color. All right, look at this one. What if I did this? What if I compared the rise and the run to this? That's a very short rise, isn't it? Compared to a lot longer run. Make sense? So this rise over run is going to be a lot smaller because this is a lot less steep, isn't it? It's a little flatter than what this one was. If I took this and I made it a little higher, then that rise is going to be higher and the run's going to be smaller. So it's going to be a different slope. So those numbers, that rise over the run, this rise over the run, tells you basically how slanted your line is. All right, that tells you how slanted your line is. So that's the rise over the run. We'll finish this tomorrow, and I'll give you a worksheet tomorrow for this stuff. So no homework tonight.
Yes.